let f of x be the quantity 4x minus 5 raised to the power of 4 times the quantity 8x squared plus 4 raised to the power of 5. And we are going to use logarithmic differentiation to find the derivative of f of x. Now, if you notice here, we have the product of two functions. So we could also use the product rule and then also use the power rule and the chain rule with this to find the derivative. However, we are trying to show you this new method so that you have another tool in your toolbox so that you can, once you get comfortable with it, you'll be able to recognize that, oh, if I use this method, it might be a little bit easier versus this method. So we're just trying to give you as many tools as possible to make things easier on you. There are times that one way will be easier than the other. There might be times where they're both equally difficult and it will just come down to a preference. So specifically for this example, we're going to use what's called logarithmic differentiation. And the idea behind this is before you take the derivative is to take the natural log of both sides of the equation, and then you can use the properties of logarithms to try to simplify things, and then take the derivative once it's simplified. So that's what we're going to do here. So the first thing I'm going to start off with is take the log of both sides of this function. So I have the natural log of f of x is equal to, now I'm going to take the natural log of the other side of this equation. So I have 4x minus 5 raised to the power of 4 times 8x squared plus 4 raised to the power of 5. Notice we did not take any derivatives yet. We're just going to use the properties of logarithms to simplify this first. So a quick review of properties of logarithms. One property that we're going to use now is if you have the natural log, and this works with logs of any bases, but we're using natural log here. Just keep in mind that this can be used for any base. If you take the natural log of, let's say, m times n, that is equivalent to saying the natural log of m plus the natural log of n. So I can split this up into an addition problem with the natural log of m and the natural log of n. So we're going to do that first. So think of this when you compare it to this rule that I just reminded you of over here. Think of this as your m and this is your n. So I'm just going to carry down the natural log of f of x, and I'm going to rewrite the natural log of 4x minus 5 raised to the 4th, and then I'm going to rewrite this using an addition sign, and then the natural log of the second factor. So I have the natural log of 8x squared plus 4 raised to the 5th. Now, a second property that we're going to use here, if I have the natural log of, say, m to the 5th, I can rewrite that by bringing the 5 down in front, and I can rewrite that as 5 times the natural log of m. So I'm going to use that here with the 4 and the 5 and the exponent. So I'm just going to keep carrying down this natural log of f of x. The 4 comes down in front of the natural log, so I have 4 natural log 4x minus 5 plus, now the 5 comes down in front as 5 natural log of 8x squared plus 4. So now that I used the properties of logarithm to simplify this a little bit, when I go to take the derivative now, it's going to be a little bit easier. So I'm going to take the derivative of both sides. So I'm going to take the derivative of the natural log of f of x, which would give me 1 over f of x. Using the chain rule, I have to multiply by the derivative of f of x. That's going to be equal to, now I'm going to take the derivative of this term right here. When I'm dealing with the derivatives of the natural log, remember it becomes a fraction, and then you multiply by whatever's the derivative of whatever's inside based on the chain rule. So I have 4 over 4x minus 5 times the derivative of 4x minus 5, which is 4, plus, now I'm going to take the derivative of the second term. So I have 5 over 8x squared plus 4 times the derivative of 8x squared plus 4, which is going to give me a 16x. So now I'm just going to have a couple more steps to finish this off. I'm just going to combine the 4 times 4. I'm just going to make this a little bit more cleaned up. So I have the 4 times the 4 that gives me 16, and that's 4x minus 5 plus, and then I have 5 times 16x, that gives me an 80x on the top over 8x squared plus 4. Last step here, we're trying to find the derivative. That's this piece right here, the f prime. I still have it being multiplied by the reciprocal of f of x. I want to isolate that derivative so I can see what it's equivalent to. So what I'm going to do is I'm going to multiply both sides of the equation by f of x so I can isolate that f prime. So now that cancels, and I'm left with the derivative of f is equal to 16 over 4x minus 5 plus 80x over 8x squared plus 4 times f of x. The f of x, our function, was, we had 4x minus 5 raised to the 4th times 8x squared plus 4 raised to the 5th. So here is our final answer for the derivative. Now, if you want to practice, you can do this using the chain rule, the product rule, and the power rule. You'd have to combine all of those. And you would still get the same answer. You should still get the same derivative. You're just going about it in a different way. So I highly suggest that if you have time, you practice doing it both ways, and that might give you a feel for when I guess you could say when one way might be easier than the other if you practice doing it both ways a few times. So to sum up real quick, when you use logarithmic differentiation, you're basically trying to take a complicated function and simplify it by taking the natural log of both sides and using the rules of logarithms to simplify it before you take the derivative. And then once you take the derivative, you have to resolve it for your f prime, and then you have your derivative. And so sometimes that's easier, sometimes it's not, but that will help you get another tool in your toolbox for you to have available when you're taking derivatives.